That's fine. Remind me again why you're not going to do it today.
I wasn't here for the past class.
It's only on the worksheets 1 and 2.
Yeah, I didn't see worksheets.
Okay, that's fine. I just wanted to make sure that we're clear.
Yeah.
Stop talking, please. Drake.
Will we have just about the quiz itself? We will have a unit circle, right?
If I need you to use the unit circle, I'm going to give you a unit circle. Not expected to have memorized. I have it memorized, but I'm a nerd. So.
If I don't have all those.
Yeah, you don't need to. I'll give it to you.
Is 4.2 on the quiz?
No.
None of the triangle stuff.
Worksheets 1 and 2. Amy.
Could you please do number 10 in worksheet 1?
10 on worksheet 1. In worksheet 1, we're asked to use the unit circle to do this. So let me go and I'm going to grab a copy of that and just drop her in there. And you said 10, right?
Yeah.
Okay. So I'm going to start by kind of drawing myself a picture. I observe by looking at my interval here that theta is a positive value. So I know when I'm labeling, I'm going to be going around counterclockwise. So 0, pi over 2, pi. So my solution is going to be either in quadrants 1 or 2. Consulting all silly turtles crawl tells me that cotangent is positive in quadrant 1 where everything is positive. So there's my theta. Now remember that cotangent is the reciprocal of tangent. So I can say that tangent is equal to 1 over root 3. And I know on the unit circle, tangent is y over x. So what this tells me is I'm going to be looking in quadrant 1, where I decided my answer is going to be, for a place where the y-coordinate has a 1 in it, and the x-coordinate has a root 3 in it. I don't need the whole x and y coordinate to be identical to that because, well, we're dividing, so you can lose some stuff in that process. So I'm looking for a place where the y-coordinate has a 1 in it, and the x-coordinate has a 3 in it. That would be pi over 6. That's my answer. Sure. Yes.
So that you could just like divide it out.
If you could divide it out and check.
Yeah, like what I would do is I just plug in like -3 over whatever, and then I would see if it matches. Like I don't know how I did it, but
Okay.
or like wait no, yeah, I do like 1 over -3, pi over 6.
Why 1 over -3?
Wait, I'm sorry, I can't talk. 1 over the root 3, right?
Okay, that's tangent. Yeah, so you guess you kind of like check the coordinates to see which one gave you that. It's the same thing. You're just going the opposite direction. That's fine. Yep. Eric? Okie dokie. So I'm just going to observe here that this is 13 over 2 is 6.5, and 15 over 2 is 7.5. Because I'm not going to write down all the labels as I go around because, woo, doggy, that's going to be a lot of labels. I'm just going to say them aloud and then start writing them when I need them. Is that okay with you guys? Okay. 0, 2, 4, 6, 6.5, 7, 7.5, So we're talking about those two quadrants right there. Is that cool with everybody? Okay. If I consult all silly turtles crawl, I know cosecant is the reciprocal of sine. So any place where cosecant is negative, sine's going to be negative. So that tells me I'm looking in quadrant 3. So let's see, 2 pi, 4 pi, 6 pi, and then to my answer. So there's my theta. My alpha is always the acute angle made between the x-axis and my terminal side. Since my theta is positive, clearly it's between two positive numbers. And the last axis that we go through before we get to the terminal side is horizontal. It tells me that I'm going to be adding alpha. So theta should be 7 pi plus alpha, where alpha is going to be sine inverse of negative. Oh, I'm sorry. What am I doing here, guys? I'm doing this as a worksheet 2 problem. I just got carried away. Anyways, I go here. This is the same thing as negative root 2 over 2. I go to the unit circle, and I'm going to look in quadrant 3 where the y-coordinate is negative root 2 over 2. So let's go do that. Doodly, 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 doo. Right here at 5 pi over 4. But remember when we drew our circle, or drew our angle theta, notice that I went around 1, 2, 3 times before I got to the terminal side. So this answer is not going to be what I need. I'm going to have to add 2 pi to that 3 times so that it actually falls in the interval that I need it to. So if I make a common denominator and add those fractions together, that gives me 29 pi over 4. Because 2 pi is 8 pi over 4. And 5 plus 8 plus 8 plus 8 is 29. And the denominator stays the same. Sorry about that. I just got carried away. Elvis.
Number 8.
Sure.
Actually, number 7.
Number 7? That's fine. No problem. Ah, what happened here? Okay. So we'll start by drawing our picture. First thing I notice is that my theta is negative. It has to be between two negative values. So when I'm going to be drawing my labels, I need to make sure I'm going clockwise instead of counterclockwise. So negative pi over 2, negative pi, and then negative 3 pi over 2. So I'm going to be looking in quadrants 2 and 3. Using all silly turtles crawl, I can see that sine is negative in quadrant 3. And again, I'm going to draw my theta. I'm going to make sure that I'm drawing it clockwise because I know theta is negative. So far, so good? Okay.
But the worksheet is
Well, let's go to the end and make sure we get the same answer. But I think this is all okay so far. So my alpha is here, right? So theta is going to be negative pi and then something alpha. Since the last axis we passed is vertical and that theta is negative, tells me we should be adding, where my alpha is sine inverse of the absolute value, negative 0.56. So do negative pi plus sine inverse of 0.56. Oops, I'm in degree mode. Great googly moogly. So I should get about negative 255. And Elvis, you say that on the key or whatever. Yeah, so here's the issue. So apparently it's a different problem because the interval was different. Ay, Mr. Kulek, what happened? I don't know. I just goofed it, I guess. So that's why it was different. I don't know. At some point the versions got changed and they didn't get updated on the keys. So that's my fault. This one is actually the easiest possible problem because the interval that you're given is just the range for sine inverse. So it's literally all you do is have to type that in your calculator and you're done. That's like the easiest possible scenario. Because this is the range for sine inverse. So just whatever it outputs on your calculator is the answer. Done. That's probably why it got changed, was because it was too easy. Elvis, you're happy? Okay. Maybe take one more and we'll be done. Sound good, guys? Anybody else want to have a go? Amy. Okay. We'll start by drawing our picture. So again, I'm going to just kind of draw a little bit of it. So 0, pi, 2 pi, 2.5 pi, 3 pi, 3.5 pi, 4 pi. So we're looking in quadrants 3 and 4. So far, so good? Okay. So all silly turtles crawl. Tells me cosine is positive in quadrant 4. So I go around to 2 pi and then around again to the terminal side. So there's my theta. There's my alpha. Since the theta is positive between two positive numbers, and the last axis we pass is vertical, I know I'm going to be subtracting alpha. So theta is going to be 4 pi minus alpha, where alpha is cosine inverse, absolute value 0.87. And then it's just calculator time. Oops. Put you over here. 4 pi minus cosine inverse 0.87. So I get 1205. Nat?
This is just a clarification question.
Yeah.
The reason you use 4 pi is because 4 pi is 2.
So yeah, when I'm figuring out what I'm going to be adding or subtracting alpha to, I'm looking at the side of the x-axis that alpha uses. And it's going to be the most recent label I wrote in there.
Okay, so it was just say it's a sign. It's a sign question, and it would be 3 pi because that's.
So if the terminal side was in quadrant 2, alpha would be the part of the x-axis that alpha uses would be the 3 pi side, so it'd be 3 pi, and then plus or minus. So it's just all in regard to alpha. Wherever alpha is, whatever part of the x-axis that alpha uses, that's the value you're going to be adding or subtracting alpha from. Okay, you guys ready? Let's do this. Point 3. Last time we had talked about describing these bearings, right? We defined what a bearing was and talked about how to convert back and forth between bearings and standard position angles. So what we're going to do here is kind of show you how we incorporate this idea. So let's run through a couple of examples here. Bye. So it says here that a boat leaves a port and averages 40 knots, that's nautical miles, traveling for 2 hours on a course of 215 degrees. And then it turns to have a bearing of 162 degrees and travels at 55 knots for 3 hours. What is the distance and bearing of the boat relative to its starting position at the port? So the idea here is we got some port. The natural place to kind of fix that would be to the origin, right? Sure. So we go on a bearing of 215. Bearings go from the north. So 90, 180, and like 35 more puts us down here. So now our boat is like over here, right? We'll make another XY axis. Actually, let's do that like. So another one of these. And this time we're going to go 162 is our bearing. So like down there. That'll get us to here. And then it's asking us, okay, that's our new final position. What is this bearing? And what is the length or the distance from there to there? Right? That's basically what the problem boils down to. Everybody okay with that idea? So the way we're going to do this is to figure out where that finishing spot is. We're going to break that trip down into like a horizontal component and a vertical component. And we're going to find those horizontal component and vertical component by getting the horizontal component from each leg of our trip and vertical component from each leg of our trip. So I know that like this distance, that horizontal or vertical component would be just the sum of those two vertical components, right? And this horizontal component would just be the sum of those two horizontal components, taking direction into account, obviously, there. So if you go to the left sum and then you go back to the right sum, those are going to kind of cancel each other out a little bit, right? Everybody okay with that notion? So that's the idea behind what we're going to do. I just wanted to draw this really confusing picture to start with, to kind of talk through what it is we're about to do computationally, so it makes a little bit more sense. But that's the idea, is we're just going to break this trip down into the two legs, and the two legs we're going to break down into horizontal and vertical components, and then deal with everything separately. So on the first leg of our journey, the bearing we're told was 215. And we're going 40 knots for 2 hours. So if I draw my picture here, I can convert that bearing into a standard position angle. So 90, 90, and then 35 is my bearing. So my standard position angle here is 90, 90, and then 55. So that becomes 235. And my distance I've covered, well, I'm going 40 nautical miles per hour for 2 hours. So that's just going to be 80 nautical miles. Everybody's okay with that? So the way I break this down then into a horizontal component that I'm going to call x1 and a vertical component that I'm going to call y1, hopefully for obvious reasons, right? X horizontal, y vertical. Yes? It was given to me in the problem.
Oh.
Yeah. So 40 knots for 2 hours. 80 nautical miles, because a knot is nautical miles per hour. Stayed in the problem. So to get the horizontal component, I'm going to just take the distance times the cosine of my standard position angle. And the same thing with the vertical component, except I'm using sine instead of cosine. Will always be cosine for the horizontal and sine for the vertical. Yup. So my bearing here, 162, puts me over here. So that's 90 and 72. So my standard position angle is here. So 90, 90, 90, and 18. So that's going to be 288. And my distance would be 55 knots times 3 hours, so 165 nautical miles. So my horizontal component is going to be 165 cosine 288 and 165 sine 288 for the vertical component. So far, so good? Remember in the initial, very beginning picture we drew, we were adding these components together to get the final location. So I'll go to my calculator to find that. Note the angle measures that we're using right now are in degrees, so I'm going to go ahead and change my calculator mode to degree. Since the last thing I was doing, things were in radians. So I have x1 is 80 cosine 235 plus x2, which is 165 cosine 288. Gives me 510. And then sine of each of those, so just the same thing with sines in the place, is negative 22246. So that's my final position. So like if this is the port, 5 over and negative, or and 222 down, is something like that, right? Everybody's cool with that idea? So my distance is going to be just the length from P to F, right? How far the boat is from the port is just going to be the distance from P to F. In geometry, how do we calculate the distance between 2 points? Oh, guys. The distance formula, okay? The distance formula is the square root of x1 minus x2 squared plus y1 minus y2 squared. In this case, notice that one of our points is the origin 0, 0. So it's just going to really turn into like the square root of x1 squared plus y1 squared. So our distance is going to be that. Will this always happen where I'm just basically doing the Pythagorean theorem on the 2 points I'm given? As long as you're picking the starting point to be at the origin, which, God help you, I don't know why you wouldn't do that. It will. You know, maybe you just are like, you know what, my life is too easy right now. I'm going to pick the starting point here to be 17 square root of 7. Like, that seems like a good spot to start this. What? No. Is that okay? And then remember the bearing is going to be this, right, from north to the terminal side. So that spot's 90. What is this going to be? That's an alpha, isn't it? Terminal side with the x-axis. So how are we going to calculate alpha in this case? Yeah, inverse tangent, absolute value, y over x. So in our case, our bearing is going to be 90 plus alpha. And it's calculator time, my dudes. 90 plus inverse tangent. As an aside, will it always be inverse tangent? Yup. And then y divided by x. Notice that I did put the absolute values in here this time on my calculator because when I retrieved the value, it was a negative sign on there. So rather than having to go back and edit the negative sign, it was actually going to be less buttons to just get the absolute value called. But whatevs. So that's 178.7 degrees. What do you guys think there? It's kind of a lot, but once you've done a couple, they're all kind of the same. Let's do one more that's a little bit different in a little bit different way. So this problem reads, a plane can travel 480 miles per hour under its own power. The pilot sets a bearing of 320 degrees. As the plane travels, the pilot notes the plane is actually traveling at a bearing of 325 degrees, going 472 miles per hour. What is the bearing and direction of the wind? Right? The wind must be pushing the plane off course and slowing it down in some way, correct? That's the only reasonable conclusion based on that story problem. You guys agree? Okay. So what's going to be the relationship between the initial, like how the pilot set the plane up, what the wind is doing and where the plane ended up. That's going to be the relationship, right? You have the initial settings for the plane. The wind is going to interact with that additively, and it's going to push it to a new location. That's the final settings for the plane. Everybody agree with that? That kind of makes logical sense, right? We take off, we set up to go this way, the wind hits us, slows us down, moves us off course to this new setting. So if I want just the wind, which is what we're asking for, I'm going to be subtracting here. So rather than adding my components, I'm going to be subtracting my components. Is everybody okay with that? Okay. So for the initial, our bearing, we're told, is 320. And our speed is 480. And our final, what we ended up going, our bearing was 325. And our speed was 472. So just like we did before, we'll draw our picture. We'll draw our bearings in here. So somewhere over here. So 90, 90, 90, and then 50. And same, well, so my standard position is 90 plus 40 more. Do the same thing over here. So 90, 90, 90, and then 55. So that's 90 and 35. Actually, let's use I's and F's, right? It's probably better. So it's going to be 125. So far, so good. Notice here that I'm not given any times, so I can't calculate any distances, right? But that's okay, because the problem isn't asking anything about distance. It wants the speed of the wind. So I can just use the speeds that I'm given. I don't have to do anything to them. Nothing to mess around with. Is that okay with you guys? Okay. So I can calculate my horizontal and vertical components now the same way that we did before. So we said before when we started, our wind is going to be the final minus the initial. So I'll go type that stuff into the old calculator. Final minus initial. So that's 37.8 and then 18.9. We'll graph where that is. So if I want my speed, that's just going to be the Pythagorean theorem or the distance formula. And then if I want the bearing, I'm just going to do 90 minus alpha. Where my alpha here is going to just be the tan inverse of y over x. And I should be probably write those absolute values in there. I don't really need them on this one because they're both positive, but you know, don't hurt nothing. So 63.4. So that wind is blowing 42 miles per hour at a bearing of 63.4 degrees. What's the big difference here between this problem and the first one? This is a subtraction problem. The first one was an addition problem, right? That's the big takeaway. Cool. So at this point, you guys should be able to now do the problems 24 through 31. So the rest of these problems here, and worksheet 7. We're going to put both of those not on this coming problem set, but the problem set for next week, which I've noted on the board here, right? Friday is the asynchronous day. We're going to treat that as a work day. We finished chapter 4 today, so that's good timing for us. Tuesday, the next time we meet, we'll take some questions and start chapter 5. And we'll do the chapter 4 test then on Thursday of next week. Sound good to you guys? And again, all the due dates and everything are in my Notre Dame. It should be accurate to the best of my knowledge.